Good morning. Welcome to the class of nonlinear optics. We have already learned some basic information, introduction about nonlinear optics. If you were missed it, please go back to the first lecture. So during this lecture, we will focus on some properties due to which we will discuss some new phenomena due to the nonlinear optics. What is a nonlinear optics? Basically, in conventional case, the induced polarization depends linearly on the electric field. That means P of t is equal to epsilon 0 chi1 E of t. That means polarization is proportional to electric. We will also neglect the higher order terms. So polarization is always proportional to the applied electric. But in case of nonlinear optics, that means by after the introduction of laser, when we are applying laser to some specific material, say some nonlinear optic material, the effect of electric field have to calculate in higher order. That means this P of t is not a single function of electric field. That will some term of E square and some E cube. That means P of t is equal to epsilon 0 into chi1 E of t plus chi2 E square plus chi3 E cube plus etc. That means we have to consider the higher order term. So this linear behavior of polarization is become non-linearity. So that is the basic idea of non-linear optics. This epsilon 0 chi1 E of t can be replaced by P of t. The second term, that is epsilon 0 chi 2 E square of t, can be replaced by P2t. So when we are talking about non-linear optics, we have to consider this chi square, chi cube, etc. These chi to the power 2, chi to the power 3 terms are basically known as second and third order nonlinear optical susceptibilities. Also, the polarization at time t depends only on the instantaneous value of the electric field strength. Now we will talk about second harmonic generation. This is one of the new phenomena due to the nonlinearity. So we have already studied by using the laser, we have to consider higher order terms. These higher order terms are represented by P2 of t and P3 of 3. Consider a laser beam whose electric field strength is known as E of t is equal to E into e raised to minus I omega t plus its conjugate. So now we will consider the P2 of t. The nonlinear polarization that is created in such a crystal is given by P2 of t. So we will pick up the second term, that is epsilon 0 chi 2 E square of t. We will neglect the higher order terms in the view of chi square. So chi to the power 2 is not is equal to 0. Then the effect of higher order terms will be in a small fraction, so that we can neglect the higher order polarization. So this P2 of t, which is equal to epsilon 0 chi 2 E square of t. Now let us substitute the value of E of t from E of t is equal to E into e raised to minus I omega. So this is chi 2 epsilon 0 into, this is 1e and this is another e. That means E square can be splitted into E into E. What is E? E raised to minus I omega t plus E raised to star E raised to I omega t. This one is the complex part. So we have epsilon 0 chi 2 into E raised to minus omega t into E plus E star E raised to I omega t into E raised to minus omega t plus E star E raised to I omega. Now we have to multiply each term. First term E raised to minus I omega t into E raised to minus I omega t plus E raised to minus I omega t into E star E raised to I omega t. That will be E into E star. So we have the second term E star E raised to I omega t into E raised to minus I omega t. That is also E into E star. So this is 2 times E into E star. So after multiplying this term, we can summarize the term is P2 of t is equal to 2 times epsilon 0 chi 2 E into E star plus epsilon 0 chi 2 E square E raised to minus I to omega t plus its complex quantity. So that means the second order polarization consists of a contribution at a zero frequency, that is the first term, and a contribution at a frequency 2 omega in the second. By now let us see this RHS of the equation. In RHS of the equation we have 2 terms primarily. First one is 2 epsilon 0 chi 2 E into E star, which does not consist of a frequency. That means a zero frequency term. And in second term we have a frequency of 2 omega. This later contribution can lead to the generation of radiation at the second harmonic frequency. So in this equation we have a e raised to minus I 2 omega. So we have a 2 omega part. So that is basically known as second harmonic frequency. First contribution in equation does not lead to the generation of electromagnetic radiation because it's second time derivative. It leads to a process known as radiation because there is no omega time. Under proper experimental condition, the process of second harmonic generation can be so efficient that nearly all of the power in the incident beam at frequency omega is converted to radiation at the second harmonic. One common use of second harmonic generation is to convert the output of a fixed frequency laser to a different spectral line. Let us see some practical application. See, we have a ruby laser. The output of ruby laser is 694 nanometer. Once you generate this 694 nanometer, now it is passing through a KDP crystal that obeys some nonlinear behaviority. See the output. Once you give a omega, you will get a 2 omega. That is 694 nanometer can be changed to a 347 nanometer. That means once you incident some omega frequency to some crystal, the output will be 2 omega. So this is the second harmonic. The input is omega, the output is 2 omega. In another case, in diag laser, we have the output 1.06 mu m. After passing a germanium p-doped silica glass fiber, we will get a 2 omega. So in this way, we can tune or we can generate a new frequency with the help of this type of KDP. What about the energy diagram? That means in energy diagram we have a ground state. From ground state, some atoms by the help of some external radiation, this atom is reached on some virtual state. This is absorption of some omega. From this virtual state also, this will reach to another virtual state. By reaching this second virtual state, if this one is emitted to the ground state with the emission of 2 omega, this is energy state. First of all, it will reach by a first virtual state by some help. If this virtual state is also have some input, by using this input, this second virtual level will also reach to the second virtual level. From that, this type of atoms will reach to a ground state by the emission of 2 omega. So this is basically second harmonic. In addition to second harmonic generation, we have a third harmonic generation. That is, let us consider the third order contribution to the nonlinear. This is our basic equation, which consists of P1 of t plus P2 of t plus P3t. We just concluded what about the P2 of t. Now we will go to P3t. That is the third order contribution. For the general case in which the field E of t is made up of several different frequency components, the expression for P3 of 3 is very complicated. That means if we are preferring the derivation is in the case of second harmonic generation, the derivation part will be more complicated. So we are going to some different ways. That means consider the simple case in which the applied field is monochromatic. The same, that means E of t is equal to E cos omega t as in the previous case. We also know that cos cube omega t is equal to 1 by 4 cos 3 omega t plus 3 by 4 cos omega t. What happened? We will just substitute this cos omega t. So we can express the nonlinear polarization as P3 of t. That is the third part in RHS. What is actually P3 of t? It is chi 3 e cube. So instead of e cube, we will substitute 1 by 4 cos 3 omega t plus 3 by 4 cos omega t. So P3 of t, which is equal to 1 by 4 epsilon 0 chi 3 e cube cos 3 omega t plus 3 by 4 epsilon 0 chi 3 e cube cos omega t. That means in this part we have to substitute, instead of e cube we will substitute 1 by 4 cos 3 omega t plus 3 by 4 cos omega t and just elaborate. So this is our last equation. The first term in equation describe a response at a frequency 3 omega that is created by an applied field at this term leads to the process of third harmonic generation. That means in equation which we have described above, which have two parts. First part which consists of omega 3 omega, which consists of cos 3 omega, and the later part which have only cos omega t. So this first part will leads to third harmonic. Before this we had explained what about the second harmonic generation. In second harmonic generation we have cos 2 omega. Instead of cos 2 omega, here we have a cos 3 omega. That leads to third harmonic generation. So this is our some basic picture. We have some material which obey chi 3 behavior, that is third harmonic generation. Omega is incident on this material, after incident on this material, the output will consist of omega and 3 omega. The energy diagram is first of all reached by a first virtual state, then second virtual, finally it is third virtual. Once reach this third virtual state, if it is going to a ground level with the emission of 3 omega. So this equation, this picture B have a energy level description, and figure A is the geometry of the interaction. So this is about the third harmonic.